So yes, I will be recording this session, and it will just be like uploaded as like a bonus session. TBH, I don't remember if I even uploaded Monday sessions. I will do that today if I have not done it. And I also do you guys ever like rehearse something you're gonna say in your head like over and over, and you're just like practicing a speech? Yeah, so I've been doing that since yesterday or this morning when I realized I like never sent you guys the chapter 16 handout, even though I promised to do it like Monday morning. And so in my head all morning I've been rehearsing like an apology, like I'm so sorry for being such a flake. And then I was like, eh. And then someone said I need a new pen color. Definitely either blue or purple, for sure. All right, so let's get started. Without further ado, let's do these. Okay, so someone sent me their team's answers, and so I'm gonna ask you guys, like one person from each team. Please give me an answer, and then if nobody wants to answer, I will default to the team that sent me a picture of their answers, if that makes sense. Okay, so 3 and 4, someone said E followed by A. And let's see if that's right. Also, I forget what group everyone was in because I wasn't paying that much attention. So when you send me your answers, just put like whatever number you were and then the answer, because I'm going to try to keep track. It's not going to end well, but it seems like everyone put E and then A. So I will write that down. And let's just make sure that's correct. So if we go through, circle this one. We know this is a strong deactivator. We know it's meta-directing. And we know that chlorine is a weak weak deactivator, and it's ortho-para-directing. So what that means, as you guys all said, E had to be put on there first since these two groups are meta to one another. So you guys are correct. E first and then A. And then I'm just looking at the chat. Which chapters are going to be on this exam? You guys are correct. It's going to be 14 through 16. I'm not sure if it'll be all of chapter 16 yet. We're waiting to hear back from Dr. West. That was I feel like I said that so weird. But yes, you are all correct. It is E and then A. So, next one up. What did you guys put for this one? And then someone said they weren't able to make it to the last session. So yes, we are doing retrosynthesis stuff. We kind of did this like a game. And you guys did all the work, and now we're going over it together. And someone said they forgot their group number. Honestly, me too. It's fine. Everyone wins. Okay, so everyone said pretty much D and then C. And you guys are correct. So let's write that in. D and then C. But before I say that, let me just double check. Yeah, okay. So one thing I want to point out that it seems all of you guys got is this is a Friedel-Crafts reaction. Right? So since this is Friedel-Crafts, we know that it could not have worked if this one had been on the ring first, because NO2 is a strong deactivator. So we know that both of these are strong deactivators and they are meta-directing. Right? So sorry, I read the chat and I got distracted. So since they are both meta-directing and they are strong deactivating groups, we know that we have to look at which one is the least deactivating when we want to pick a director, right? But in this case, since we're going backwards, we have to think, oh, does it matter which one came first? And if this was any other strong deactivator, no, it wouldn't matter. But in this case, D must come before C because it is Friedel-Crafts. I feel like I said that really weird, but I hope that made sense. If not, let me know. You guys all got it right, so I'm assuming you got what I meant. Okay, so for 7 and 8, what did you guys put? Ooh, everyone's putting E and then C. And so that means you guys chose this group going on first, followed by this group. And so as we just said, let's go ahead and write down, this is a strong deactivator, so it's meta-directing. This is also a strong deactivator, and it's meta-directing. And the groups are meta to one another. So you guys all said E and then C. Why couldn't it be C and then E? I would like a brave soul. So everyone is pretty much saying NO2 is a much stronger deactivator. True. NO2 is less reactive. True. It does make benzene less reactive. True. You guys are all right. Everything you're saying is valid. So SO2 is more reactive. True. But the tricky thing here is that even though all of those are true, and technically this is the most favorable order of reactions, the other way could also happen. So with all the rules that we talked about, E followed by C is the most favorable because we're putting the less deactivating group on first, but nothing is stopping it from happening the other way. It is possible that this one could have been put on first, followed by this one. So in this case, either could have happened, and that is what I am showing you guys with this double-sided arrow. And then someone said, on the exam, you won't have both options. No. On the exam, it'll be more straightforward. Like, he'll give you, like, I don't know what I'm saying. I lost my train of thought. So on the exam, you won't have, like, both options. It'll be either E first and then C, or I don't know. It'll be something obvious that it won't have either way. Just conceptually, there might be a concept question that says, like, oh, which one had to be added first? And you know that they're both possibly added first because of what I said before. And then in the chat, people are asking questions. Okay, so someone said, why can that happen? So basically, it can happen either way because they are meta to one another, and they're both strong deactivating groups, right? And we know that they are meta to one another, right? We can see that, and they're both meta-directing. So at that point, we can't really see which one had to go first because they're both meta-directing, and they did both end up meta to one another. What you guys were saying is completely valid, and I completely agree with you, that it makes more sense for SO3H to be added first, followed by NO2, because that's the most favorable order of reactions, because this one is less deactivating than NO2 is. Completely correct. So the most, what's it called? The most favorable order of reactions would be E followed by C. But it is possible that it could have happened the other way. That's why I put this arrow like this. Because technically, if you added NO2 first and you did a sulfonation, it would add just like this. Less favorable, but it would be just like that. And then, so I thought of a better way to phrase it to the person who asked how it would be on the exam. So on the exam, he would probably just ask which of the following is the most favorable way. And so if he says most favorable, you know it has to be E followed by C. But he could ask, is it possible to be added multiple ways, yes, it's possible to have multiple ways because it could either be E followed by C or it could be C followed by E. Okay, someone said thank you for explaining, so hopefully I'm not just speaking in gibberish. And then someone said refer to the cheat sheet I gave you guys for 14 and 15. And then that was really funny. I'm glad you think it's helpful. It made me laugh. Okay, so next one. And then someone asked which cheat sheet. Okay, so I sent you guys this. I'm actually glad you asked. So I sent you guys this cheat sheet that was basically just like the rules of arithmeticity, and then like those extra rules, and then MO theory, and then a whole bunch of examples. And then we went into 15, and I gave you guys this like little diagram that has all of the reactions, the little mechanism, and the little Friedel-Crafts points here. And then it gives you kind of the order of reactivity and the resonance structures to show you why it is the way it is. And then I give you all of the activators and deactivators like in table form, just in case you guys don't like the list form. It goes in order. I think I forgot to mention this. So it goes most activating in order to least activating, and same here. So this goes to least activating. And I will show you guys, what was I going to say? I will send you guys a cheat sheet for the rest of Chapter 15 and Chapter 16. I just didn't want to send it to you before we covered it in SI. So back to this, and I sent that to you guys via email. So if you didn't get it, check your email. And if you still don't see it, send me an email and I will be happy to send it to you. Okay, so we finished the first row. Yay. What did you guys get for this one? B and then D. Cool. So B is the alkylation, D is the acylation, and Friedel-Crafts. They're both Friedel-Crafts, so I'm going to write that down. And B had to come first because one reason is this is a ortho-para activator, and this is a meta-strong deactivator. And since these two groups are ortho to one another, you know that this had to be added first. In addition, we know that this had to be added first because both reactions are Friedel-Crafts, and alkylation cannot happen after acylation. And I have a concept question to throw in there. What is a possible unwanted effect that can happen with alkylation? A couple people said it, but it was only like one or two, so I want a couple more people to respond. So yes, rearrangements is one, and polysubstitution. Cool. Those concepts will for sure be on there one way or another. So alkylation can have rearrangements or polysubstitution. Cool. Next one, 11 and 12. What did you guys put? B followed by A seems to be the consensus. So you guys said that this had to be first. It is an activator. It's ortho-para directing. And chlorine, which is a weak deactivator, and it is ortho-para directing, had to be second. And I'm guessing you guys said that because this is an activator, this is a deactivator, so this one had to have come first. Could this also be the other way? Yes. Okay, perfect. And that's Friedel Crafts. But Friedel Crafts can happen with chlorine because that's a weak deactivator. So I'll put the little arrow here. It could have also been the other way. But you guys gave me the most stable, or the most favorable order. So that's why I wrote B and then A. I'm blabbering at this point. Okay, so 13 and 14, what did you guys put? D, E. Alrighty. And so again, remember this is Friedel Crafts. So D had to be first because even though these are both meta directors, sorry, I got distracted by the chat. I'll answer your question in a second. So Friedel Crafts had to be first because it cannot happen once there is a strong deactivator added. So I'll just write strong deactivator, meta directing, strong deactivator, meta directing. But this was Friedel Crafts. And then someone had asked, why is it that this can be reversed? That's a great question. So it can be added the other way as well because both groups are ortho-para directing. So if you just look at it, they are ortho to one another. Either one could have done that. So that was kind of a weird way to say that. So either one could have been added first. We can't tell which one it was because they are ortho and both groups are ortho-para directing. So since they're para to one another and both groups are ortho-para directing, we couldn't tell for sure which one was added first. But as you guys said, B followed by A would be the most favorable order because this is an activator and it would make the benzene ring more reactive while this one would deactivate the ring. Does that make a little bit more sense? Yes? Okay, yay! Alrighty, so let's scroll down. What did you guys put for 15 and 16? Okay, seems like most of you guys put C and then A. And can that be reversed? No, exactly. And the reason it cannot be reversed is this is a strong deactivator, so it's meta directing. And we know that this is a weak deactivator and it's ortho-para directing. And since these are meta to one another, this one had to come first. Correct. Cool. So let's go on to 17 and 18. What did you guys put? I got 2 groups answers, 3. Okay, cool. So D and then C. So remember, this is Friedel Crafts. And these groups are meta to each other, right? Strong deactivator, meta directing, strong deactivator, meta directing. Could this be reversed? No, and you guys are 100% correct if you said no, because if this one had been placed on first, Friedel Crafts could not have happened. So we know that this had to be first. No flip-flopping. Cool, perfect. You guys are doing amazing. So the last 3 are a lot harder than the rest of them because they are tri-substituted. So you guys are already giving me the answers. You guys are awesome. But I just wanted to zoom out and let you guys see it for a second. Okay. So we are getting a couple different answers in the chat, and that is awesome. So let's go through and write chlorine is what kind of group? Weak deactivator. Cool. So we know it's ortho-para. NO2 is what kind of group? Strong deactivator, so we know that it's meta. Cool. And then the R group is what kind of group? And yes, for you guys, it's just a CH3, but someone pointed out that that wasn't a choice, so I fixed it. Yes, it is a activator, and it's technically a weak activator, but I'm not going to confuse you, so I'll just write activator, and that means it's ortho-para directing. Cool. So we know that we have a Friedel Crafts happening, so that's something else that you have to keep in mind. So we know that whatever we do, NO2 had to come after the Friedel Crafts. And the chlorine doesn't really matter as long as it comes, it doesn't matter whether it comes before or after the Friedel Crafts because it's a weak deactivator, so Friedel Crafts could still happen. And chlorine and NO2 are meta to one another, but also you can think of it as chlorine is para to this, what is it called? The R group, and this is ortho to the R group. So we have two big possibilities. And before I say that, someone said, how do we know it's Friedel Crafts? So if an R group or a ketone like this are added, that's Friedel Crafts. So ketone is the acylation, and R group is the alkylation. So to this one, we could have had, which one is? Okay, so B could have been first because that is the R group. And then we could have had C, which is the NO2. And then we could have had A. Or we could have had B, A, C. Or we could have had A, B, C. Let me move this over a little bit because it's cramped up in the corner. So any of these three could have been possible because remember, the most activating one on the ring will be the director. And either way, we could get this confirmation. This, I guess I can call it a confirmation because these two are ortho to one another. These two are para, and yes, these two are meta, but that doesn't necessarily mean that this one had to do the directing because they are ortho and para compared to the R group. And so the most favorable way to do it would be BAC. So I'll highlight it. This would be the most favorable way to do it. And the reason it would be most favorable is because you would add the most deactivating one last. And someone said, would he ask this on the exam? Probably not, because this is complicated. There's too many answers. But I want you guys to be able to do this, because if you can figure this one out and think it through, you'll be able to do anything on the exam easy peasy. You're welcome. Okay. So this next one, what did you guys put? While you guys are telling me, I'll go ahead and write what kind of groups they are. Okay, so I'm getting DEA and DAE, so let me write both of those down. And let's look at it. So D would be the acylation, and I'm glad you guys put that before SO3H because we know that that wouldn't work because it's Friedel Crafts. And we can see that these groups are all meta to one another. So chlorine could not have been first because that is the most activating, and it would have had to direct ortho and para. But remember, the most activating group is going to direct the next group added. So if we had added D and then A, this group would have to be ortho or para compared to the chlorine. So because of this, only one option is possible, and it's going to be DEA. And I can repeat that if anyone needs me to. Yes, I will repeat it again. Sorry, I was reading the chat. Okay, so yes, most people are asking kind of the same question. So chlorine could not be first or second. It has to be last because all of the groups are meta to one another, right? And so let's say we did chlorine first. That would mean they have to, by they, I mean the second and third groups, would have to be added ortho or para, right? So we're going to go ahead and say this one was first because we said chlorine can't be first, and if this was first, Friedel Crafts could never happen. So, okay, good. We have to add this one first. Once we have this group on, it's a meta director. So let's say we think chlorine is second. Cool, it adds meta. But when we're adding this group, between chlorine and the ketone, chlorine will be the most activating. So then it would direct the next group, ortho or para. Since it's meta, the third group, we know that chlorine had to be last because there's no way for chlorine to be added first or second and for us to get all meta to one another. Does that make more sense-ish? Okay. Someone said yes. If anyone needs more clarification, please let me know. We shall go to the next one. So, what'd you guys put for this one? Okay, so some people are saying BAC and some people are saying BCA. So let's take a look. I'll write both BCA, BAC. So we have our Friedel Crafts, and we know that it is a activator and it's ortho para directing. We know that this is a weak deactivator, ortho para directing. Last but not least, we know this is a strong deactivator and it's meta directing. Okay, and so we can see that this one is a little bit different than the previous one because they're not all, They're not all meta to one another. So you guys said BCA. I think most people said BCA, so we'll do that first. So B is saying that this one was first, and then we added NO2, and then we added chlorine. And this one will work because of the same reasoning as the last one. So if we added Friedel Crafts first, perfect, we're all good. And then we add chlorine, and it is added ortho. Between chlorine and an R group, R is the most activating, so NO2 will be added para to it. Cool, checks out, that works. BAC, oh, sorry, I explained BAC, but I said BCA, my bad. So BAC does work. because if we were comparing chlorine and the R group, chlorine would win, and it would direct NO2 para to it. That works. BCA would also work because if we had the R group added and then we add NO2, cool, that's para, it works. And then when we're adding chlorine between NO2 and the R group, we know that the R group would be the director because it's the most activating. And so it would add the chlorine ortho to it. So that also works. There is one more option that works that you guys didn't mention, but that's okay. So it could also be A, B, C. And the reason it could be A, B, C is because chlorine could be added first, and then Friedel-Crafts could happen, and they are ortho to one another, right? And then once Friedel-Crafts has been added, it will be the director, and so NO2 can be added last, and it will be para to the R group. In my opinion, this one is the most complicated one. So does anyone have any questions about how I got the answers that I did? So the most favorable one would be this one. And that is because we're adding the most deactivating group last. So that would be the most favorable one. Okay, so I'm going to zoom out and show you guys the answers. And yes, I can explain the last one more time. So the reason we have 3 different answers possible is because we can, sorry, I don't know why I started my sentence like that. It's because all of the groups are ortho and para to one another. Yes, the NO2 and the Cl3 are meta, but that's not like the point. If you look at it, you can see that even though they're meta to one another, NO2 is still para to the R group and Cl3 is still ortho to the R group. So compared to the R group, everything is ortho or para. And NO2 has to come after the R group. That's the only thing that we know for sure. It has to come after the R group. And as we can see in all 3 answers, C comes after B, so that checks out. The reason we can have, I'm going to zoom in. The reason we can have A come before B is because chlorine is a weak deactivator and it's ortho-para directing. So if this was put on the group first, on the benzene ring first, then we can add this group, the R group, and it will be ortho. And then now, when these 2 are on the ring, and we go for our 3rd substitution, we know that the R group will be the most favorable to then direct the next reaction, and that's because it is the stronger activator of the 2. So NO2 can be added para to this group. So that's why this last one can work. The middle one can work because we can add Friedel-Crafts, and then after Friedel-Crafts, we can just add the chlorine, and that will be ortho to it. And then again, same explanation for the last step. Between these 2, this is going to be added based on the directing effects of the R group. And for this first one, we added Friedel-Crafts again, but then we added the NO2, and that was added based on the directing effects of the R group. And then when we look at the addition of chlorine, we would have to use this as a directing group again, because we know that NO2 is a really, really strong deactivator. So the R group will be the director, and chlorine will be added ortho to the R group. I know this one is really kind of convoluted sounding. But does that sort of kind of make it make more sense? Sure. I feel that. Okay. If you're still kind of confused on it, we can come back to this later, but I really, really want to move on to chapter 16 for now. Someone said I'll do tutoring. That's fair. Okay. So, yay, we are done with chapter 15. I hope you guys had fun with this game. Now we are going to move on to chapter 16. And okay, I'm gonna just go ahead and open. No. Okay. So we're going to go ahead and actually, no, I lied. We're not going to do that. We'll just start here. Sorry. Okay. So this is the chapter 16 handout. I sent it to you guys on Canvas as an announcement. And I was just going to go ahead and show you guys the summary, but I actually want to do the conceptual stuff first. So we're going to do that right now. So the first concept that we have to look at is acid and base catalysts. So we talked about this a little bit previously, but it's super, super, super important now. So how do you guys think an acid catalyst versus a base catalyst will affect the reaction? And guesses are totally fine. I just want to know what you guys think. So we got a couple really great answers. So both of them will speed up the reaction. This is true. A couple people said that the acid will make the electrophile more electrophilic. And that is true. And someone else said that the base makes the nucleophile more nucleophilic. And I don't know why I wrote that so much bigger. It's fine. So, I'm going to say this about a bajillion times between now and the end of the semester, but it's very, very important. Acid catalysts make the electrophile more electrophilic, and a base catalyst will make the nucleophile more nucleophilic. Very, 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 very important. And in all of these reactions, every single one, we're going to... Okay, Bear, calm down. We are going to use a carbonyl. So every reaction is essentially going to be carbonyl plus some reagent plus some catalyst is going to give you some answer, right? And in every single reaction, the carbonyl will act as a... What do you guys think? What does a carbonyl usually act as? Electrophile. Cool. You guys are totally 100% correct. And I'll actually do that in a different color. So in every single reaction in chapter 16, the carbonyl will be the electrophile. Okay. Any questions on the conceptual stuff before we move on? It doesn't seem like it. we'll do the naming stuff afterwards. So for now, I'm going to open up a new page. And I'm just going to do all of these reactions, but on a separate page, just because I don't like how much space I've given myself. But I will name each reaction so nobody gets confused. So today we will probably only have time for one reaction, so we'll keep working on these on Friday. But the first one we are going to do is the gem diol reaction. Oh shoot, someone just reminded me. Someone said we never learned the name of the common names of the benzene rings. So you're right, that's completely my bad. I will send you guys I will include that on the cheat sheet and I will send that to you guys. And I will put it as the first thing we cover on Friday. Just so you guys get it in an SI session too. There's just a couple of them. I will send it to you as its own thing today. Or I will try to at least, because I forgot about that completely. So that's my bad. Thank you for reminding me though. Okay. So for the gem diol reaction, let's start with a ketone. And for the gem diol reaction, our reagents are going to be H2O and some catalyst. And so we're going to do one example with an acid and one example with a base. And someone said at the end of the session, can I scroll up? Yes, I will zoom out and show you guys all the notes at the end of the session. So in the first example, let's do H2O with an acid catalyst. So let's just use HCl as our acid. Right? And someone asked, so H2O will always be the reagent. Yes. So for these reactions, I will point out, because most of them will have a special name for the reagent. For this one, it's just H2O. So gem diol reaction will always be H2O with either an acid or a base. I'm choosing to do the acid reaction first. So the acid catalyst is going to do what? That we talked about on the last page. It's going to make the carbonyl more electrophilic. Yes, so by that, it's going to steal a hydrogen from the from the acid. And so we get a plus charge on the oxygen because it has been protonated. And so at this point, the H2O can act like a what? If this is going to be the electrophile, what do you think? Nucleophile, yes. So this will attack here. Bam. These electrons go up here. So we get our OH. And we just added our H2O. So what do we have left over floating in solution that can deprotonate this? Cl minus, exactly. So in the next step, we have our Cl minus, which is going to snatch one of those hydrogens, give those electrons back to the oxygen. And so our product will be OH on one side, and after being deprotonated, we get an OH on the other side. And this is our final product. And someone said it's a diol. Exactly. And so it is a geminal diol. And you guys remember way back a few chapters ago when we learned about the geminal position? And I said that would be important when we come back to it. Well, it's important here because you know that geminal just means it is on on the same carbon. And so it is a diol with both OHs on the same carbon. And someone said, do you need to know the mechanism? So on the exam, you won't be tested on the mechanism, but I think the mechanism is important because if you understand the mechanism, it's so much easier to answer these questions. But short answer, I guess, is no, because you won't be tested on the mechanisms. You're welcome. Okay. So if we did this exact same reaction, but we had a base instead of an acid, it'll pretty much be the same, except, let's say I give you OH minus and H2O. The first step will no longer be making the electrophile more electrophilic. Instead, it will be what? Making the nucleophile more nucleophilic. Exactly. So if we zoom in, this OH is going to steal a hydrogen. Oh, what am I doing? And we're going to give the electrons back to the oxygen. So we didn't really do much in the first step except make our nucleophile have a negative charge, which makes it more nucleophilic. And now we made H2O. And I know it kind of seems like this first step was all for no reason because you still end up with an OH and an H2O. But pretty much this could have been any base. I just chose OH because it's the most common one. So I know it seems like a useless first step, but just trust me, there's a method to the madness. Okay, so at this point, the nucleophile attacks, kicking up these electrons. So we end up with an O minus. It has all those extra electrons. And we added an OH. And now we have to protonate in the last step, and we have this handy-dandy H2O. So the oxygen with a negative charge will steal a hydrogen, give those electrons back to the OH. And so now we've ended up with OH here. And another OH here, and we still have some base in the solution. So again, we have ended up with the gem diol. So whether you use an acid or a base, you still end up with the same result. And I want to go back and actually fix a little technical thing. So I gave you guys regular arrows here, but I just want you to be aware that they are equilibrium arrows. So this is going to be a reversible reaction. All of these are going to be reversible reactions, essentially. I will point out if they are not, but just keep in mind that all of the reactions in this chapter pretty much are going to be reversible. So I'll go ahead and fix those arrows. And then someone asked, is there one catalyst that makes the reaction, or is there one that catalyzes the reaction more? So in this case, no, they're going to be pretty much equal. There will be some reactions that will only work with one or the other, or it will be important to note which one's better, but in this case, they're pretty much equal. And yes, all the reactions in this chapter are going to be reversible unless I say that they're not. So I will specify if they are not reversible, but they will pretty much all be reversible. Okay, so we are going to end it here. I just wanted to do the gem dial reaction. We didn't get as far as I wanted to. So we might do an extra session on Friday. I just have to figure out my life, and I will let you guys know. But I will most probably end up doing it on Friday. Would you guys be interested in that? Doing another session from 12 to 1 like we did today? Yes? Okay, cool. So we'll do that. I will zoom out and I can't do both at the same time. But yeah. So I will see you guys on Friday. To all the people who are signed up for tutoring, I haven't sent you the thing yet. I will send it to you right now. That's my bad. Oh, you're so nice. Thank you. You guys are very welcome. Bye.